Welcome, Algebra 2. This is section 3-2, Solving Systems Algebraically. The essential question is, what are some methods to solving systems algebraically? Let's begin. So a lot of this might be review for you. If you do, just skip over what you can. What are systems of equations? Systems of equations is a set of equations that we have to use both equations or the multiple equations to figure out what our solutions are. So what you used to before is just having one equation, like you say x plus 5 equals 2. Well, what does x have to equal? X has to equal -3, and that's the only one solution. Well, if I gave you an equation x plus y equals 5, well, you could have an infinite number of solutions. You could have x is 1, y is 4, you do the ordered pair 2, 3, you have 5, 0, you have -2, 7. There's actually an infinite number of solutions to this. When you have a system of equations, and the point is you have multiple variables in here, and we use those system of equations to figure out what the actual one solution is. So if I had the two system of equations x plus y equals 5 and 2x minus y equals 1, there is only one possible solution, and that is 2, 3. Because I'm going to plug this in and show you. If you plug in 2 for x and 3 for y, you get 2 plus 3 equals 5, and that's 5 equals 5, and that checks out. Over here you get 2 times 2 minus 3 equals 1, and that'd be 4 minus 3 equals 1, and that's 1 equals 1, and that checks out. If you tried plugging in some of these other ones, that would not work out. The only solution that works is 2, 3. So the point of system of equations, we have to find that one solution that works for both equations. So one solution for both equations. So use both equations together to find the one solution. There's a few ways we can solve this. And two ways we can do it, we're going to talk about doing it algebraically. So using some math. So substitution method and elimination method. Let's do substitution method first. So with substitution method, we isolate the variable, so it's one of the variables, and then we substitute it into the other equation. So watch what I do in this example. I see this y, I want to isolate this y here, so I'm going to take this bottom equation and subtract 2x on both sides. So I'm going to get y equals 10 minus 2x. Now I got this equation, y equals 10 minus 2x. I'm going to take this 10 minus 2x part and substitute it in for y of the top equation. So let's rewrite that top equation. It's going to be 3x plus 4 times, I'll do this in that gold color, it's going to be, or this, no, let's do it in the red. So this 10, instead of saying y, we say 10 minus 2x. Alright? So 4 times 10 minus 2x equals 12. And now I'm taking this equation, there's only one variable and I can solve for x. So what I'm going to do, I'm going to distribute. So I get 40 minus 8x, and this is going to be 3x, plus 40 minus 8x equals 12. Combine the 3 minus 8, so that's going to be 40 minus 5x equals 12. I'm going to subtract 40 on both sides, so I get negative 5x equals negative 28. And then I will divide by negative 5 on both sides. And so you're going to get x, and that cancels out, equals negative, trying to have a negative will be a positive, and that's going to be 28 over 5, which is also, if I wrote it as a decimal, it's going to be 5.6. So that's my solution for x. However, I need to find the solution to both variables. So I take that 5.6 and plug it in to figure out y. And I can use either equation. I'm going to use this equation because I like this one. So see this 2x plus y equals 10? We're going to substitute this 5 minus 6, this 5.6 right here. I'm going to substitute this in for x right over here. So this is going all the way over to this x. So what is that new equation going to look like? 2 times, and I'm substituting this in, 5.6 plus y equals 10. Okay, so 2 times 5.6 is going to be 11 and 2/10 plus y equals 10. And to isolate the y, I have to get rid of this 11.2. So I subtract 11.2. And what you're going to get is you're going to get y equals negative 1.2. So those are my solutions, x and y. It's an ordered, it's a pair. So I'm going to write that as an ordered pair, 5.6 comma negative 1.2. And this is the final solution. So this is the one solution that satisfies both equations. Let's try another example right here. So I'm going to use substitution method again. And this should be equals 5. Okay. So what I want to do in this case, and you can substitute either variable. It's it's when a variable is isolated like this x, that's going to be easier to substitute. So what I'm going to do, I should do instead, I'm going to just rewrite all those. So I'm going to rewrite this x plus 3y. I'm going to subtract that 3y. Let's actually do the work over here. So x plus 3y equals 5. And what I'm going to do is I want to move that 3y out of there. So I subtract 3y on both sides. So then I get a new equation, x equals 5 minus 3y. And I'm going to substitute this 5 minus 3y in for the x of the second equation. So this is going to go all the way over here. So my new second equation when I substitute is negative 2 times the quantity 5 minus 3y minus 4y equals negative 5. Now let's solve for y. So I'm going to distribute and I get negative 10 plus 6y minus 4y equals 5, or negative 5. And then combine those y's, I get 2y. So I get negative 10 plus 2y equals negative 5. I'm going to add 10 to both sides. So I get 2y equals positive 5. And if you divide by 2 for the last step, you're going to get y equals 5 halves. I'm going to leave it as 5 halves. That's the first part. So I got to solve for x. And I can use any equation. I'm going to use this top one right here. So I'm going to be plugging in 5 halves in for the y. So then I'm going to get, in that new equation, x plus 3 times the 5 halves. Okay, so I'm going to go 5 halves. And then it's going to be equals 5. Well, so what I get is 3 times 5 halves is going to be 15 halves. So x plus 15 halves equals 5. Alright, well, I'm going to convert that to a decimal. So x plus 7.5 equals 5. And I'm going to subtract 7.5 on both sides. When you do that, x equals negative 2 and 5/10. So negative 2.5. So that's my x, that's my y. I want to write that as an ordered pair at the bottom. I'm going to go negative 2.5, and y is going to be 5 halves, or you can write that as positive 2.5. That's your solution. All right. Here's a real world example. So you got to actually create these, and you read this. So a music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee of materials are shown in the advertisement. What is the cost of each lesson and the one-time fee for materials? So when you're reading these problems, you have to figure out what your two variables are. And that usually comes from the question, what is the cost of each lesson? I'm going to call that x. And then what is the one-time fee for materials? We'll call that y. So we've got to figure out those two variables. And the two equations are going to come from this node up here. So the price does include a one-time fee. So 6 lessons is going to cost $300. So 6 times the cost of each lesson, so x of them, plus the one-time fee y is going to equal 300. That's from the first one. Now if you have 12 lessons, it's going to be 12x plus that one-time fee is going to add up to 480. So there's my system I have to solve. And I can solve by substitution. I'm going to rearrange this top one over here, subtract 6x on each side, so I get y equals negative 6x plus 300. So if I know y equals all this, I'm going to substitute that in for the second equation, y. So my new equation is going to be 12x plus, parentheses, I'll keep it in parentheses, it's going to be negative 6x plus 300, just to show my substitution, equals 480. And now let's solve. So that's, these parentheses actually don't matter, but let's rewrite that. 12x, it's not going to be plus, it'll be minus 6x plus 300 equals 480. 12x minus 6x is 6x plus 300 equals 480. Subtract 300 on both sides, you're going to get 6x equals 180, and divide by 6, and your x is going to equal 30. So the cost of each lesson, x is going to be $30 right now. Now we got to figure out what is the one-time fee for materials. Well, let's plug that 30 in for x and solve for y. So I can use this green equation right here. I'm going to plug this 30 right into this one. So I rewrite that green equation. It's going to be y equals negative 6 times 30, and then it's going to be plus 300. So what's that going to be? Negative 180 plus 300 and then that's going to add up to y equals 120. So what's the one-time fee for materials? Y. That equals $120. So your answers are right here. The cost of each lesson is 30. The one-time fee is 120. All right. Another way to solve is by elimination. So this is when you add or subtract the equation so one variable is eliminated. So in this case here, if I add both these equations up, and they're all lined up with the variables, 4x minus 4x, cancels. 2y plus 3y is going to be 5y, equals 9 plus 16 is 25. So to isolate the variable y, I divide by 5 on both sides, and then you're going to get y equals 5. So that's the first part. But I got to still solve for x. So I just take one of these equations, plug in y, and solve for x. I'll just use the top one. It doesn't matter which equation you use. 4x plus 2 times what's y? It's going to be 5, and then it's going to be equals 9. So when you got all that, well, it's going to be 4x plus 10 equals 9. And I'm going to subtract 10 on both sides. So we get 4x equals negative 1. Divide by 4, and I get x equals negative 1/4. So my total answer here, or the ordered pair, is going to look like negative 1/4, 5. And that's your solving by elimination. So this is helpful if it's just easy to add or subtract. It doesn't matter if you use substitution or elimination. It's just whatever way it makes sense to you. So sometimes when you solve by elimination, you need to multiply one or both of the equations to get variables to eliminate. So in this example, if you just added these up, they wouldn't eliminate. Just added these up doesn't eliminate. So let's say I want to eliminate the x's, and you can choose whatever one. You have to multiply. Basically, you want to get the LCM. The goal here is to get the LCM. Or another way is you could say is just multiply by the opposite number. So for 2x, I'm going to multiply this one by 3 because the 3 is down here. And down here, I'll multiply this by 2. But to make these cancel out, you're going to need to make one of them negative, so I'm going to multiply it by negative 2 on the bottom. So what happens when I multiply everything on each equation by those? I'll put the work over here on this side. It's going to be 6x plus 21y equals 12. And this one's going to be negative 6x minus 10y equals positive 10. So if you add those two equations up, the 6x and negative 6x cancels out. 21y minus 10y is 11y. And 12 plus 10 is going to be 22. So you divide by 11 on both sides, and y is going to equal 2. So that's the first half. Let's solve for x. I can take any equation. I'll just take the top one. So it's going to be 2x plus 7 times the 2 for the y is being plugged in equals 4. So then I get 2x plus 14 equals 4. And subtract 14 on both sides. What you're going to get is 2x equals negative 10. And divide by 2, and x equals negative 5. So then your final answer here, as an ordered pair, is going to be negative 5, 2. Solution. All right, we have some unique solutions here. So sometimes when you eliminate or you're solving a system, the things cancel out. So if I added these up, I'd get 0 equals 0. Well, in that case, what you have is infinite solutions. It doesn't matter what you put in for x and y. You can put any numbers in for x and y, and those will always work. So we say there's infinite solutions. Now, what if it happens in the case if you add them up and you get something like 0 equals 16? This doesn't make sense. We say it's no solution. There's not any values for x or y in the whole wide world that'll make this work for this system of equations. Similar to what you've seen before. I said before, if it makes sense, it's infinite, or all real numbers in other cases. And if it doesn't make sense, there's no solution or no real values. All right, pause the video, try this out. Alright, I'm going to solve by substitution. I am going to subtract 2x on both sides of the equation here. I do that arrow. So then I get y equals 4 minus 2x. I'm going to substitute this 4 minus 2x in for the y in this top equation. So if I rewrite that, it's going to look like 3x plus 5 times the quantity. What's this? 4 minus 2x. And then it's going to equal 13. Well, then you get, let's solve for x. 3x plus 5 times 4 is 20, and 5 times negative 2 is minus 10x equals 13. Combining like terms, 3x minus 10x combines to negative 7x. So you have 20 minus 7x equals 13. And I want to get rid of that 20. So subtract 20 on both sides. And what you're going to get is negative 7x equals negative 7 Last step here, I divide by -7 on both sides. I'm going to get x equals +1. So if x equals +1, let's plug it into some equation and solve. I'm going to plug that +1, let's plug it into this equation. It's the easiest one to mess with. It doesn't matter which one you pick. So then I'm going to get 2 times 1 plus y equals 4. So I get 2 plus y equals 4. Subtract 2 on both sides. You're going to get y equals 2. So x is 1, y is 2. Your final solution as an ordered pair is 1, 2. Try the next one. Pause the video. Okay, I'm going to solve by elimination. So let's say, is this the same one I just did? No, it's not. Okay, so let's say I want to get rid of the x's. So I'm going to choose to multiply the top one by 2 and the bottom one by -3. That will eliminate it. So when you distribute the -3 and the 2's, this will be -6x minus 9y equals -63. And the top one will be 6x plus 8y equals 20. So when you add those up now, the x's cancel out. 8 minus 9 is -1y, or just -y, equals 20 minus 63 is -43. I'm going to divide by -1 on both sides, so you get y equals +43. So that's the first part. I will plug in 43, this 43, into one of those equations. Let's use the bottom one. Doesn't matter. So I'm going to get 2x plus 3 times 43 equals 7. So what that's going to give me is 2x times 3 times 43. 2 times 3 is 9. That's going to be 129 equals 7. I'm going to subtract 129 from both sides. So those cancel out. I get 2x equals -122. Divide by 2. I'm going to get x equals -61. So that's the solution for x. My final ordered pair is going to look like -61, 43. Last one. Almost. What are the solutions? So this is, okay, let's see if I wanted to eliminate the x's here. I'm just going to multiply the top by 2. I don't need to multiply the bottom. So what happens when you multiply the top by 2, it's going to become -2x plus 2y equals -4. And the bottom is just going to stay the same. 2x minus 2y equals 0. So if we add these up, what happens? -2, that should be +2. This is just +2x, that was a typo. So -2 plus 2 cancels. The y's cancel out, so I get 0 equals -4. Does 0 equal -4? No. So we say no solutions. This is one of those special cases. No solutions for x work out. Let's try this one. So if I wanted to eliminate let's say I want to eliminate the x's. I'm going to multiply the top one by -3. And so by doing that, I'll get the new equation -12x minus 3y equals -18. And on the bottom, let's just leave it as 12x plus 3y equals +18. If you add these up, the x's cancel out. The y's cancel out, so you get 0, and you get 18, that's also 0. So does 0 equal 0? Yes, this works out. So what we say is there's infinite solutions. Solutions. That's it.